Hi, everybody. Can you hear me okay? I'm Salvador, fossil preparator, behind the glass in the PJ exhibit.
Hi, and I'm Natalie. I work with Salvador up in the fossil preparation lab. So Salvador and I, as fossil preparators, our job has two parts to it. The first part is doing what you see us do in the prehistoric journey exhibit, which is scraping the dirt off of fossils. And then the second part of our job is what we're going to talk a little bit about today, which is going out to the field to find the fossils with teams of researchers, with interns, with volunteers, all kinds of different folks, different collaborators from around the world. So today we're going to share with you a little bit about our trip that we went on to Peru last month in the search for the last Cretaceous ecosystems of Peru, or the KPG boundary in the southern hemisphere. All right, so for folks that have been a part of the DMNS community for a while, you may be familiar with the KPG extinction. It's something that our team here at the Denver Museum works a lot with. So we're talking about this moment in time right before and right after all of the non-avian dinosaurs go extinct on Earth. And this is about 66 million years ago. And what's really special about this chunk of time is that we're able to go across the American West to collect data to better understand the last dinosaur ecosystems of North America. So everywhere that there's a star on this map are all of the places that Salvador and I have the opportunity to go and participate in fieldwork to collect data to learn more about the KPG boundary. Some of those areas, if we start on a very, very local level, are areas like this. So in Colorado, down in Highlands Ranch in 2019, Salvador and I get a call that they bumped into some chunks of fossil out at a construction site in Highlands Ranch. And it turned out to be a Torosaurus, a horned dinosaur, and got a lot of really cool media attention. So we have dinosaurs literally in our backyards here in Denver. And what's really special is that if we go a little bit farther south, we have the other side of the boundary, just an hour south of Denver. So in Colorado Springs in 2019, Tyler and his colleagues worked on this really amazing discovery of the recovery event after the extinction of the dinosaurs. So we have this really awesome snapshot in time that is preserved here on a very local level. Also, we have these things that continue to happen here in the Denver Basin. In 2017, if folks were here, we found another horned dinosaur. And of course, even before my time at the museum, they've been finding dinosaurs across the Denver metro area. So Coors Field, there's a reason that Dinger is Dinger, and that's because they found part of a horned dinosaur underneath of home plate, as the story goes. But we have this really amazing long history of finding fossils from this moment in time right before the dinosaurs go extinct. If we go a little bit farther away, farther north and up to North Dakota, Tyler and some of you all may remember Dr. Kirk Johnson, who worked here several years ago. But what's really special is this area up in North Dakota, you can actually go put your finger on this moment in time, right? So Tyler and Kirk are touching the KPG boundary, and so you can find dinosaurs below that. You will not find dinosaurs above that. And some of you may recognize this fossil that has been around in the museum now with Alex for a number of months, but we're really lucky in that when we go to these areas like North Dakota, we're able to get this really beautiful snapshot of dinosaurs that were around in their last ecosystems before the moment when they go extinct. And then even when we travel to the other side of the globe in places like Madagascar, where Dave Krause and Pat O'Connor have been working for decades to collect fossils from the late Cretaceous of Madagascar to better understand what those dinosaur ecosystems, well, I guess I should also say and mammal ecosystems, looked like before dinosaurs go extinct at this moment in time. And the way in which we do that is we go out to the field with a whole bunch of folks and we try to collect more fossils to better understand this moment. So we oftentimes, in the Department of Earth Sciences, hire a bunch of interns to come with us to help us find these really remarkable fossils. So this was our intern squad from the year of Teen Rex. And this is one intern in particular. His name is Mario. And Mario was our intern in 2024. He is from Lima, Peru. And he finished his bachelor's degree in Lima in 2023. And he joined our team here at DMNS last summer. And so Mario came and interned with us in the fossil preparation lab, where he learned all the different tools and techniques and methods by which we clean and stabilize vertebrate fossils. And as a result of some of his time here and gaining these new skills, he was able to secure a job at a place called INHEMET, which is basically the equivalent of the USGS in Peru. And because of Mario's training and his love for fossils, he he was able to work on this really spectacular fossil of a crocodile-type animal that received a boatload of media attention across all of South America and even internationally. And so Mario, has this amazing skill set. He came to work with us here in Denver in the field and in the lab. And Peru is really spectacular in that it has a pretty broad geologic record. So every single color that you see on this geologic map of Peru represents a different moment in time. And you can see in the upper right corner there that there's a lot of yellow that is represented on this map, and those are all rocks from after the time period of the dinosaurs. So these are Paleocene rocks, and even some much, much later into geologic time. So they have this really rich fossil record, specifically of fossils from the Miocene. Really incredible things like fossils of whales and dolphins. This is a fossil crocodile skull from the Amazon. So they have this really, really amazingly rich record. But if there's one thing that you know about Mario after meeting him for 5 minutes, it's that Mario loves dinosaurs. And although he had the opportunity to work on all of these incredible fossils from these other moments in time, they were not dinosaur fossils. And so Mario is interested in finding the last dinosaurs that were walking around in Peru 66 million years ago. So if we return back to our geologic map here, there are rocks from this moment in time, which we call the Cretaceous, right, the late Cretaceous. So if we look at this map, this lime green color that you see scattered across the map, and if we focus here on the southern part of Peru, and we zoom in to this red box here, all of the colors that you see in this box that are this kind of lime green and dark green color by this little town called Puno by Lake Titicaca has some of these rocks that could potentially record the last dinosaur ecosystems of Peru. So one of these rock units that we worked in is called the Vilquechico Formation, and this is from this latest Cretaceous time period.
Yeah, can I use that? Thanks. So when we're out in the field, we're not just looking for fossils, we're also looking at the geology. And something really special about the KPG boundary is that there are a few places in the world where you can walk up the hill and put your finger on that line in the sand where the dinosaurs went extinct and the age of the mammals begins. So this here's from North Dakota. And one of the things that points to that line of the sand is when the asteroid impacted the Earth, it shot all of what was called ejecta up into outer space, and that rained down as tiny glass beads called spherules all over the Western Hemisphere, and in some locations these spherules are preserved. We have a great example of this that you can see on display in the T-Rex exhibit from Wyoming, where you've got Cretaceous below, Paleocene above, and if we zoom in, you can see all these little glass beads, these spherules, preserved right at the KPG boundary. Now, if we look at a map of the globe and all of the different KPG boundaries all over the globe, you can see there's kind of a blank spot right in the middle of South America here. The closest to where we headed in January is Gorgonía, an island in Colombia that has some incredible spherules preserved. So we knew that spherules did rain down relatively near to where we were headed and hoped that maybe this was a possibility of something else we could find. And so 4 of us from DMNS, Natalie and myself, as well as Dr. Tyler Leeson and Dr. Jake Wilson, our new postdoc studying fish, all hopped in a plane after Mario invited us down to go to Peru because this was a really incredible experience. We didn't want to, this is not an invitation we wanted to pass up. So we went to Lima, Peru first to meet all the folks in paleontology that Mario knew in Lima and to make all sorts of different stops there. So first we stopped at the University of San Marcos, where Tyler gave a talk about kind of the beginning talk of this talk, talking about all of Teen Rex and the work we do in North America, the work below the KPG boundary, and then the recovery of the mammals afterward. And it was a little bit of a small audience because it was their summer down there, but this is one of the most engaged groups with so many incredible questions that I have ever seen. We then went to go visit their Natural History Museum, and something that was really interesting for Natalie and myself at the Natural History Museum was to see their prep lab. This is their preparator, Walter, who Natalie is talking to right here. And I don't know about you, Natalie, but I am so jealous that Walter gets to work outside because it's never 0 degrees like it was last week in Denver, in Lima, Peru. But they've got different techniques they use there, and they have all sorts of really cool fossils. Here is a Manuel with a Basilosaurus in the upper left corner, a whale from just about 4 hours south of Lima. Here's some other really cool dolphin fossils, mammoths, more recent things, of course. And one really interesting technique that they used that we do not need to use here is the rocks that they're collecting a lot of their fossils from are super salt rich. And in order to get that salt out so that they can use glue appropriately and have long-term preservation of the fossils, they have to soak, here's a swordfish skull, soaking in a water bath to get all of the water out of those fossils. So really cool to see different techniques at this lab for preparators like ourselves. The last stop that we made was in Jimét, where Mario worked after returning to Peru last summer. Basically the Peruvian Geological Survey. It was their National Day of Paleontology when we were there, so they had some cool fossils out on display, including the gharial that Mario prepped when he was working for them. And so here's that gharial right there. And we also met all of the folks who were responsible for helping Mario get his permits to go collect fossils in southern Peru. So after our time in Lima, all of us were, of course, chomping at the bit to get out on the rocks. So we flew down to the Puno region, right near Lake Titicaca in southern Peru. And first there, we visited the University of Puno, which has a great geology department. And of course, we flew down there, not just the 4 of us from DMNS and Mario, but Mario's collaborators who flew down with us included Abel and Manuel. Abel was the geologist who really had the vision. He's been working down both of these folks are from Lima, but Abel has been working down in Puno for several years collecting trilobites in the Devonian, and he had the vision, not a lot of people have looked at this Vilquechico rock unit. Maybe we should go check it out. And Manuel studies histology with crocodiles and is also, like Mario, super, super interested in finding Peruvian dinosaurs. And so at the university there, Tyler gave a talk, and this one was a little bit different. In rural Peru, there was almost everybody spoke exclusively Spanish, and some folks spoke a little bit of Quechua as well. And so Mario translated the talk for Tyler. So Tyler would give one little blurb per slide, and Mario would ramble on and say and fill in all the gaps and improve on the talk. Did a wonderful job presenting the work on the KPG boundary that DMNS does in North America to this southern Peruvian audience. So the first field site we went out to was called Laguna Umayo, which was an interesting place to go. Not only is there a potential KPG boundary area there, there is also some geologic or anthropologic history there. So there are these chulpas up on top of the hill next to the lake, and it was the rainy season we were there, so it's very green. And all that greenery made it a little bit hard to look at the rocks. But one of the things, all of the rocks in the Vilquechico are dated based on charophyte data. So the little hard parts of freshwater algae gets preserved, and you can use those to tell time and tell when the KPG boundary potentially happened. And at Laguna Umayo, in the past, the first scientists who went down and wrote things about Laguna Umayo in the late 20th century were very confident that they were looking at Cretaceous rocks. They got some undoubtedly dinosaurian eggshell fragments up here. But later on, folks found mammal teeth in this area. Then they thought, hey, wait a minute, maybe these rocks are actually much later. These are really derived mammals that couldn't have lived right after the dinosaur extinction. So there's kind of a question mark and a debate for this particular region. But we looked around and eventually found some fossils in what's probably a historic site along this road cut. And so we found a nice little chunk of turtle for Tyler. So there's a little, this is the turtle's belly, and here's the armpit right here. And here's another piece of turtle, a turtle hip bone in the corner here. So we collected these pieces of turtle with some of the students from the local university. This is Denitza and Anderson and Nazaret from the University of Puno, all geology students there, making their very first plaster jackets. And we also collected some rock there, because this was a conglomerate that had other tiny bits of bone, and we figured this was the kind of rock that people had found mammal teeth and potential dinosaur eggshell fragments from in the past. So we bagged these rocks up, and the next day, Jake and Anderson and I smashed these rocks with hammers, because it was pretty hard and we didn't think we'd be able to melt them down with water, looking for tiny fossils. And we did find some tiny fossils. We found bits of croc teeth, and also maybe we found dinosaur eggshell fragments. Fortunately, Manuel does thin sectioning, so he is planning to work on these and hopefully get a better answer as to whether or not we found dinosaur eggshell. That same day, Natalie went on a totally separate adventure. So she hopped in this tiny van with the rest of the crew, and I'll let her tell that story.
I've never felt so tall in my entire life. So this is the van that me and Tyler and Jake and the whole Salvador and the Peruvian crew spent several days crammed in the back of this tiny van, so lots of great time together. So while Salvador is working with the students and teaching all the students at the University of Puno, Tyler, myself, and some of our Puno colleagues went to this field area called Vilquechico in the town of Vilquechico. And what's interesting about Vilquechico, so we know that this rock unit, the Vilquechico Formation, is from the late Cretaceous, and there has been preliminary work that's been done in this area. However, the things that folks have found, the most notable things I'd say, are a track site with these hadrosauroid footprints, and then also, it's highlighted here, fish remains, and then some miscellaneous bone fragments. So that was it for the entire Vilquechico Formation. So we started our adventure in Vilquechico by stopping here at the police station, or I guess it's really like a city municipal building type of place. And we had to meet with all of the local officials. So these folks that are in these beautiful red pieces of clothing, this was the town's lieutenant. And we also met with different authority figures. This is Senor Newton. He's one of the professors at the University of Puno. So we had to stop here and just get everything stamped and approved that we could work in the different field areas in the town of Vilquechico. And everybody was very kind, very welcoming. It was one of our very first days in this area, and so one of the police officers told us, yes, okay, no problem, but there's one last thing you all have to do before you can go collect fossils. And Tyler and I are like, okay, sounds great, what do we got to do? So we get in the back of a car, and we travel to the top of this giant mountain that they call a volcano, and at the top of this volcano is a giant concrete statue of Jesus. And they tell Tyler and I that they need to perform this traditional native dance so that we can have their approval and have their blessing to go collect fossils from their land. And this was really special, just an incredible cultural experience to be a part of. And when I say we were a part of it, I mean that Tyler and I also had to get up and dance with these folks during the cultural celebration, which was really remarkable and really special. Definitely a core memory, really spectacular. But after that, everybody just kind of scattered, and the guy said, all right, you can go out and collect whatever you want now, you're good to go. And we were like, sounds great. So with that and with their blessing, we were able to start heading out to the different field areas. And right out of the gate, we found some pretty spectacular sedimentary structures. There's lots and lots of rock exposed in this area. Really, really beautiful ripple marks all over the place that are indicative of some type of coastal environment. What was unique about this area is that the rocks that Salvador and I mostly work in North America are all terrestrial deposits, mudstones and siltstones and sandstones, things like that. We traditionally don't work in marine or coastal deposits, so it was really spectacular to see such beautiful sedimentary structures like this. Some of the other things that we were noticing that we were getting excited about right out of the gate, these are little burrows from invertebrates that you see, little gastropod traces, and then even some mud cracks that are on the far right there. And we go out prospecting all day, and a couple days go by, and this is what we found. And we're so excited, right? Tyler is over the moon because it's a piece of a turtle. But this is, the first turtle fossil that has ever been documented from the Vilquechico Formation. So we were excited about that. However, Salvador and I wanted more. We needed more. We've been out there hiking around miles and miles across all these different rock deposits. And in addition, Salvador mentioned it's the rainy season. So our commute every morning looked a lot like this, where we're driving through the rain and the sludge and these flooded streets. We also are getting all different kinds of weather elements, including hail. And
hey, Manuel.
Laughing through the tears.
So intense.
But, morale is not the highest it could be, right? We found one turtle bone over the course of several days. And of course, we're thinking, oh my goodness, do we come all the way to South America and we just found this one turtle bone? I'm not sure. However.
So we decided we would bounce around Vilquechico a little bit more and go to a new area. And the sun came out the same day that everybody kind of all at once cracked the fossil code. And so we figured out we needed to be a little bit higher in section than where we had been looking before. So on that opening slide, you saw sort of the variegated red and green rocks, and we had got those big sandy ripple layers. And once we went a little bit higher in section, we found this relatively thick gray-blue shale, and we started to find lots of fossils there. So I started to find little pieces of fish skull on the right here, as well as something that maybe is part of a marine reptile humerus on the left side here. And at the same time, Natalie and Tyler both found these awesome croc fossils. Tyler found a little coracoid, and Natalie's got a vertebrae there. And then as we keep looking around in this area, we find the first fossil that's really going into the ground. And so we quickly, as the sun was going down at the end of the day, dug in and collected this little bit of a turtle fossil in our first little plaster jacket in Peru.
So morale is high again, right? We're riding the fossil high. And just as Salvador said, we've kind of dialed in where we need to be in section and what kind of rocks we need to be looking in order to be successful paleontologists. So we go to a new field area. We're still working in these marine deposits. We have this kind of low-lying gray, bluish, reddish colored shale. And out of the gate, Salvador finds this. And this little thing you see here is the top of a crocodile skull. If we do a little flippy-roo here, I forgot we did the... You can see that there's the little tooth poking out of the front of the snout there, which would be, more or less there in a modern crocodile skull. But this is the first kind of fully intact, really exciting fossil that we're finding in this layer. And so again, putting these things in plaster, we're getting fired up, super excited. This is Salvador with Tyler and Manuel, and here's another view of that fossil, an anterior view where you can really see that broken off front tooth sticking out of the ground. And it's just a little guy, but really spectacular. Here's some pieces of turtle that we found. We were hiking around, piece of a turtle limb there on the right. And we head off to our last field area, and Tyler was the happiest I've ever seen him. We are on our last 2 days of working in the field, and Tyler finds this turtle. And what was so remarkable about this is that even Tyler looking at it was like, this is something unusual. This is not like something that I have even seen before. And is that because we're working in these marine deposits, or is it because it's something new in South America or in the turtle world? Stay tuned, we're not sure. One of the challenges that we had as we were making all these different plaster jackets for these different fossils was going out to find burlap. It was nearly impossible to find something that was made out of, like cotton that didn't have any type of synthetic material mixed in with it. You can imagine if you're taking synthetic material and dunking it into liquid plaster, it's all just gonna fall right off. It's not gonna hold. And so we ended up driving around. We probably stopped at, 6 different stores in the market, and nobody had what we were looking for until we found this man who had a roll of burlap on the side of the market street, which was great. And here's Tyler working with the students to get this fossil ready to be collected. In the same field area, we were finding pieces of a crocodile limb. Here's another view of that turtle. The students were starting to find fossils too, which was so spectacular. So here's this huge chunk of a vertebrae, we're not quite sure, but maybe another piece of this big marine reptile that Salvador had found a piece of at our other field locality. Some more pieces of crocodile, the spectacularly preserved three-dimensional fossil fish skull-looking thing. Here's the top of a fish skull, and which is a pretty substantial size if you see the scale of how it's being held in his hand. Salvador working with the students to collect some more pieces of fossil turtle, and then Tyler working with the students was so spectacular to have their first kind of big field jacket experience. So working on undercutting this and putting the plaster cap on everything. Here's everybody, all smiles, and then we had to put some rope into this little field jacket along with a couple sticks to reinforce it. Also finding plaster in Puno or in the area was also pretty difficult. We found this cementy type material that was similar but also just didn't dry. So everything was a little bit floppy, a little bit soggy, but we made it work. And then Salvador, the students, really we all just took turns carrying this fossil down to our field truck the tiny van that was parked at the bottom of the hill. And then Salvador went with one of our collaborators from Lima to go bring this to a shipping center and send it back to Lima, where it will be worked on at INHMET with Mario and his team. And so as a reminder, these are the things that we knew before we went out to the field area in the Vilquechico formation. So before we had this amazing collaborative opportunity in Peru. And afterwards, I'm pretty excited that we found all these different critters and creatures that were completely unknown from this rock unit before we went out there with Mario and his team. So we're hoping that we'll be back. We're hoping that Mario invites us back. But overall, just a really positive, really successful experience. And it was really fun to be with the students when they got to have kind of some of their first paleontological, traditional field experiences in the sense of making plaster jackets and finding fossils, going prospecting, et cetera, et cetera. So the stoke level is high, the interest is there, and we're really excited about that.
So before you ask what's next for this project, this is a strat column from a 1993 paper, one of the best papers on the Vilquechico formation. And all of these question marks are part of that original paper in this figure here. And these question marks are still question marks. So there's definitely some work that needs to be done in terms of figuring out where in time we are in the Vilquechico. I think there are a lot of modern geological sedimentological techniques that could be used, like paleomagnetics, to try and figure out a little closer in time where we are and to hone in on that line in the sand where the KPG boundary might be. Mario, for Mario's part, he is in Barcelona right now, finishing his master's degree, and then afterward he's coming to hang out with us next summer in the Hell Creek in North Dakota one more time, and hopefully in the future he'll be doing what he's doing in this photo here, putting his finger on the KPG boundary, except this time in Peru. Also, when Mario gets back to Lima from North Dakota, he's going to be working on preparing all of the fossils that we had shipped back to Lima at INHMET, and he's working on figuring out how to invite the students from Puno up to Lima to work with him. Thank you so much to all of the collaborators and people who made this possible. Really wouldn't have been able to go on this expedition without help from so many people, specifically Stephen and Mary Lynn Neller, who funded the expedition, as well as David Portugal and Susie Reyes, who live in Lima and offered us tons of information and logistical help while we were down there, as well as all of our many, many collaborators in Peru and the folks who kept things running in the lab back here while we were away. Any questions?
Thank you.
Plenty of time for questions? I won't make you catch it, Jordan.
Thank you. That was really interesting. I'm just wondering, why is it so hard to pinpoint the KPG boundary? It seems like, it would be ubiquitous given that the debris and the spherules fell seemingly everywhere on Earth. Is it about locating that place in time? Or what are the conditions necessary to for it to be there, for you to find it?
Yeah, I think a lot of it is just being able to look in the right place at the right time, right? Where, this is a moment in geologic time where this instance happened. And I think that even being able, Salvador and I were really surprised by kind of the lack of geologic control that's on any of these rock units. So although we were collecting these things from the Vilquechico formation, it's plus or minus, 2 million years on either side. And so if you think of it, I guess, in terms of like a geologic moment, like the KPG impact versus all of the suite of rock that we have to walk through to figure out where we are in section, it's pretty challenging. I don't know if there's anything else you want to add.
Yeah, I think there are a lot of pieces that have to come together to put your finger on the KPG boundary. There has to be, the rock from the KPG impact has to be deposited, and then it can't get washed away. It has to be buried right after that. And then 66 million years later, it has to be exposed on the surface. There's probably plenty that were preserved and aren't exposed on the surface. So just lots of pieces of the puzzle.
Yeah, that's a good question.
Thank you for that presentation. Those were some beautiful fossils. So it looks like you guys had a lot of students with you. Is there a PhD granting option? Is there a way for them to continue working on the stuff with Mario there?
That's something that Mario is working on with the universities in Lima and with Puno. The Paleo program at Puno University is pretty young. Most of the students working there are planning on going into mining, and most of their classes are teaching mining. There definitely is interest in paleontology. There were all sorts of invertebrate fossils from older rocks that had been collected there at the university, but that's something that is still growing for sure.
The fossils come first, and then the interest follows.
Thought I saw other hands.
Great talk, guys. Was there any evidence for any ash fall layers anywhere?
No.
I didn't see any ashes.
Oh, okay.
Not yet.
It is interesting that everything except the question mark plesiosaur would be survivors of.
I thought that was pretty interesting too.
All right. Just in a general sense, when you're surveying an area that's so widespread like that doesn't have a lot of geological research done on it, and you're trying to identify the layers and so forth, what kind of materials are datable? I mean, if you went and did a wide survey and took a lot of samples and tried to figure out the dates of the layers there that have uplifted and intermixed, what kind of datable materials are in something like that?
Yeah, so Salvador had mentioned one of the tools that we can use is paleomagnetics. And so we know, like down with Gussie and Tyler's project down in Coral Bluffs, we've been able to really refine the age that's down there using reversals in the magnetic poles and being able to understand if we're either at a normal pole or a reverse pole. And that's kind of like the 30,000 foot first step in understanding where we are in geologic time. We can also use things like fossil pollen. Jeff had just asked about fossil ash beds. And, these are all things that we, of course, would love to find and dive deeper into. But, we were there for such a short snapshot of time that it's hard to, I guess, dial in where we are in geologic section, in addition to, keeping our eyes peeled to collect all of this other paleodating information at the same. I guess all I'm trying to say is it's very preliminary, and there's lots more work to be done. But
Now that we have nice vertebrate fossils from the Vilquechico, if we get the invite back, the priority will be trying to figure out where we are in time.
Thanks, you guys. That was great. So just when you're out there, how do you decide that's a good place to go dig?
That's a great question.
do you have any ideas?
Abel and Manuel and Mario had put together maps of the region and all of the Cretaceous rocks and exposures of Vilquechico and the Muñani Formation above it in the area. So looking at these Google Earth files that they had put together was a good start. Then we'd switch to looking at satellite imagery to try and figure out where is their rock actually exposed, and it's not a terraced hillside or just covered in grass or trees or what have you, a place where we can actually go look for rocks. So lots of times zooming around on Google Earth is probably the biggest help.
I could just say no, that's cool. You were above Lake.
Sorry, I have to ask you to use the, only because we're recording these? Thank you.
Speed up the process for you. You're above Lake Titicaca, so that's above 12,000 feet, right? Or it's way up there, and you were finding fossils from the seabed. So that was like being pushed up a very far distance, actually. Anything you found otherwise? I mean, did you go lower at all, or is it because you went to the KP and you want to go above it?
So the Lake Titicaca and Vilquechico are kind of right in the middle of the Peruvian Altiplano, so there's a mountain range on both sides. And in the Cretaceous, there was a seaway coming north-south through South America there. And this was sort of at the end of that seaway, kind of similar to the same time right here in geologic history. But so that was at sea level 66 million years ago. And since then, the Peruvian Andes have pushed the Altiplano up to Lake Titicaca is about 12,500 feet now. And that was the only area we were looking for fossils on this trip.
So you went to the marine realm, where I like being. Yay! So you really questionable where you are quite in time. I was wondering if you had a sense of where you were in space, like in relationship to that shoreline, like onshore, offshore, at any point, because looks like there's a very rudimentary sequence stratigraphy done there based on one of the figures you showed, but that could help you with predictability a lot.
Yeah, I think we, the first few days we were finding 0 fossils, but just lots of sedimentary structures. Absolutely, did notice a nice kind of transgressive regressive type of sequence, especially when we're getting those beautiful ripple marks. However, I will say that in terms of understanding where, I guess most of the fossils seem to be coming out of this really fine-grained shale. And once we started finding fossils in that is just, we were laser focused in on that. So we didn't go back to the coast. Yes, absolutely.
You were probably right to do that if you wanted fossils that were intact. Also look there if you want to find ash.
Other questions? I'll be right there.
So you guys said you're familiar with the KT boundary in terrestrial areas, and this is the first time you worked in. Are there good marine examples of the KPG boundary, or is there something about a marine environment that would make it harder to actually find that?
That's a great question. That map that we showed with all the KPG boundaries all over the globe, Almost all of those are marine, because in marine environments you have more consistent, calm deposition generally, as opposed to terrestrial environments. And we're interested in terrestrial animals primarily here at the Denver Museum of Nature and Science and Paleontology. But yeah, there are definitely lots of examples of the KPG boundary in marine rocks.
Any other questions? Let's thank Natalie and Salvador for a great talk.